What is computational thinking? In technical terms, computational thinking can be defined as the thought processes involved in formulating problems and their solutions, so that the solutions are represented in a form that can be effectively carried out by an information processing agent. This means thinking about the solution to a problem in the form of making a computer do something for us by giving the solution in algorithmic form. Computational thinking confronts the riddle of machine intelligence. The Google definition of computational thinking builds on this idea by providing a breakdown of the elements involved in this process, which include decomposition, pattern recognition, abstraction, and algorithm design. This is what each element involves. Decomposition involves breaking down what is needed. Pattern recognition involves deciding what is going to happen. Abstraction involves simplifying certain aspects. And algorithm design involves writing a code. Though these terms may sound complicated and specific to computing and programming, we can apply them to our own thinking in situations as simple as making a pizza. Here is an example of how. First, we decompose what ingredients and toppings are needed. Then, we decide on the pattern of how we want to make it. Next, we decide to cut toppings in advance to simplify the process. And finally, we create a code by writing the instructions for how to make it. This example shows how computational thinking and algorithms are not only relevant to computers, but are actually used within our day-to-day lives, and one place in which they are used extensively is within the school environment. Although it may not be immediately clear, teachers think computationally within their daily teaching and planning, where they decompose what they need to teach, recognise patterns in how to teach this, abstract by differentiating tasks, and write a code in the form of a lesson plan. There are also elements of this within teaching strategies such as questioning, which is displayed here through Skinner's algorithm. In terms of children and their use of computational thinking, it is already present within several aspects of their work, although we need to be putting more emphasis on using the terms computational thinking and algorithms. Though this may seem above the level of primary education, in the new national curriculum it is a requirement that children in Key Stage 1 understand what algorithms are. Here are some other requirements from the new national curriculum related to computational thinking. So you may ask, why do we need to teach children computational thinking if they are already using it within their daily activities? Barr and Stevenson state that the power of computational thinking is that it applies to every other type of reasoning, and if children are able to grasp the ideas of computational thinking and algorithms within their daily learning, they will find it easier when it comes to using it on the computer with programs like Scratch. But how can we teach this? Well, as we have seen, computational thinking is not only applicable to the confines of a computer, so there are opportunities to teach it throughout the curriculum. For example, on my block school experience, I taught a lesson in geography where the children were creating routes in the playground for their partner to follow. The children were using computational thinking throughout this activity, through decomposing what language they needed to use, identifying what they wanted their partner to do, simplifying this with the use of straight lines rather than curved, and finally giving an algorithm for how to reach the end. This was part of a geography lesson in which children were learning directional language, but there are many other areas of the curriculum that could incorporate the use of such computational thinking. For example, when working out calculations in maths, writing instructions in literacy, and even carrying out experiments in science. They can make this a fun experience, with interactive activities such as writing instructions for making a jam sandwich and testing these instructions out on a pretend robot within the classroom. To conclude, computational thinking is a type of thinking that someone does when solving a problem, whereby they think about the solution in relation to computers and how they might be able to solve the problem for us. In terms of teaching this type of thinking, in my view, it should be done without computers across all areas of the curriculum before beginning to use computers and different programs. It is vital that children begin to think in this way, as computers and information technology are ever growing and will be a big part of their future.